Hello guys, good morning, good afternoon, depending on which time you're watching this video. Well, today's class will be asynchronous too, which means that it will be recorded. So, um, but at this point, you already must have your assembly for your toy pretty much done. Um, However, there's still a few things that we haven't seen yet, and I'm gonna show you that in today's class. So let's start by opening up our our toy assembly. In this case, it is a robot. So it is pretty much done already. It already has all the restrictions, geometric restrictions, etc. There's a few missing, and we will be adding them today. So it looks like this because on last class we were trying to create a scene and see how this panel works with the appearances. So it's very easy. You have this panel open right here, and to add an appearance you just um, hold and release in the part that you want to modify. So as easy as that. You can change how your robot looks. Let's see that you want to add a specific material to a specific part. Let's say that you want the head to be steel. So you click, and in this panel it will ask you which part or which section of this part one will be affected by this material. So it can be only the face that you selected, or it can be the whole solid, the part, or the whole assembly. So in this case, I'm just gonna set the material for the whole assembly, and there you go. So this is only for us to help us look the robot better and to make realistic renders. But today we won't be doing that. We will be adding the restrictions that we are missing here. So these arms turn around as they should. Let me just make this material transparent, so it's easier for us to see what's going on. Actually, it's not letting me see what's up. So we want to be looking at the part like this. Okay, so to make any material transparent, we right click and then we set the part to be transparent or not. However, as I added a material, I think it is affecting the ability to look through the material. So what I wanted to do, it was to show you how the parts interact and that they don't have any restriction or interference between the parts. So maybe we cannot see that, but we can run the analysis right here. So we will set this assembly and then calculate. So far so good, no interference is detected. So now let's try moving the head. It won't also it won't cause any interference either, as it is not touching anything. However, if we click and drag on the legs, we see that they do have interference with our part. If we run the analysis, it will highlight the parts that we are having interference with. So that would be an error, at least for the simulation for this assembly. So there is an easy way to fix that. So this restriction is a little bit more, well, it can help us look or simulate how the parts touch. So in a regular assembly, this part or this leg will collide with this front part, which is the torso front, and it won't move any further. So to simulate that, we can add a range of motion that it's allowed. And to do that, we will be selecting a face, in this case this one, and a parallel face, this one. And now let's set the relationship by clicking here on mates or positional relationships. And right here, we already have seen all of these, but now let's check this one, advanced relation positional relationships. And right here, we can add um, a distance, a range of motion in distance, or a range of motion in degrees. So in this case, I'm going to set up to be in degrees. And I just happen to know that I want the leg to move 15 degrees forward and 15 degrees backwards. So right here, we have the maximum distance, which would be 15 degrees, and the minimum distance would be minus 15 degrees because it moves both ways. And here we can set any value, say 0, to set it parallel to this face, and we click OK. So now when I click and drag, it will stop precisely on the range of motion that we have established. So if we see right here, it is not touching. However, we can run the analysis here. So calculate interference detection, and no interference is detected. So we're okay. So now let's add that very same restriction to this other leg. So we click here, and assembly, and then we'll go to advanced mates, and then we will select degrees. So we can set it up to 0, and right here we can set a maximum of 15 degrees and a minimum of 15 degrees. So let's see. Oops. 30, no, 15 and minus 15. We will set this to 0. So let's see if I did this okay. I think not. So maybe this one is the right. So let's try to redo this restriction again. Let's see what did I do wrong. So this phase with this phase. Now we'll go here to advanced, and right here we will click on 15 degrees, minus 15 degrees, and set this up to 0. There you go. Okay, now it's working. I don't know what I did wrong, but anyways. So that's how you may do these restrictions. Okay, texture appearances. Okay. Okay guys, so let's continue. Actually I had to pause the video to see how to turn off the appearances because I wanted to show you this command to show the transparency in order for us to see what's going on inside of our part. So I did that by clicking right here on edit appearances. I select the whole assembly and then I just click here on remove appearance. So that is the way to recover this transparency function for the assembly. So I wanted to do that because now if if this was a real 3D printed toy, it would fall apart, right? Because there's really nothing holding these parts together unless we used some sort of glue. But as we normally don't do that, let's find a way to add a screw to hold these parts together, and also maybe to add some lip right here to avoid the part from spinning or turning it around. Anyway, so let's do that. And so the idea is that I will add a screw right here and I will add a pole in the front to be able to hold the part. Also, I will add some lips right here to avoid the part from twisting and after the assembly. Okay, so I will click here and let's see if I can right click and open the part, and we can find that command here, edit part. And what I want to do actually is to open up in this part um, in the origin in a different drawing. So I think there is a way to do that. However, as I don't remember right now, I will just click here on open and I will click on head front because I already have it right there. Okay. So I want the pole that will have the hole for the screw to be right here in the middle. So we will see the normal view and then add a new drawing. We can add a line here to here, and this will allow us to hover and get the midpoint, which is the center for the head. Okay, so this will be the pole. Let's add some dimensions to it. So 0.5, I believe it's fine. Actually, well, yeah, it's fine. And now features extrude, and I want this extrusion to end right here where the assembly would end. So we will say it is up to a surface and this is the surface. There you go. Now we want to add a hole here, and this hole will allow us to set um, the hole for the screw. Okay, so we click here and maybe we would need to add a center point. So we will add a point right there. So we will use this point later to add the hole. Okay, so we have here an assistant for drilling, and as this would be a hole for a screw that is self-tapping, which means that it will create the the, the hole for it to I'm sorry, I just forgot that for a second. So yeah, what it will do is just to create a hole. We don't need to add any. En español la palabra es macholeado, and it is the path for the screw, right? But as we won't be needing that, as it is a self tapping screw, we only will add a hole as is, so right here. But we will say which kind of screw we're going to use. Maybe an M4, it's okay. And right here we will go to positions, and there you go. But we want this to be not through all, only for half a centimeter, I believe so. Okay, let's see how this works, and then we'll go back. However, there was something else that I wanted to do. So remember, this is an M4 and half centimeter deep, but we wanted to add lips in order for avoiding the part to turn. Okay, so if we had the two parts right there just assembled as it is in this sketch, in this assembly, the parts will turn, right? Let me try to explain. So this part right here, it will be only held by one pivot point right here, which means that the other part may twist. So at the end, we may be able to have this. So to avoid this, we will add some lips here that will create a mechanical restriction for the part to turn around. Okay, we go back to the head, and the lip has to be, I believe we can have one here and maybe two here, and I think that would be enough. So we will be using this space to create a sketch. Okay, and click again, and let's say we want to create a new sketch. So um, we want the sketch to be more or less like this. And so let's define the thickness for this, and let's say it is 2 millimeters thick, and the width, let's say it's 5 millimeters thick. There you go. Now let's add another two right there. Normal view to the sketch, just to reset the view. I think we can use this type of maybe I can, okay, actually I think we can use this line right here as a reference point, and there you go. So let's use the same dimensions that we used before, so we can whether use millimeters or just have don't write any units, because right now we are working in centimeters, so it's the same. Okay, now we want to have the same operation but done right here. Okay, so only to create a fully defined line, I will say these two lines are coincident, are convenient, and let's do the symmetry. Okay, so we select the unit, the lines that we'll use for the symmetry and their reference point. There you go. So now let's extrude this, and actually I believe To hold it in place, we will need to do an extrusion backwards, right? So features, extrude. Now let's change the direction and say 2 millimeters. Okay, so this part will be set to this point. Now we can use this same reference point to create the front part. So new sketch. Normal view to this sketch. And let's try the okay, features, extrusion, and let's extrude it 2 millimeters. So now it can hold or avoid the part from turning. Maybe we can get a better grip in the molding if this were a part that were created in a mold by creating here an angle. So there we go. Let me see if I can find it. No, right here, plan. 1 millimeter. And let's try to reduce this one, but in all the others. Okay, more or less like that. We could have the same um, operation right there, but as it is only for demonstration, it's okay. So now if we see our part, we see that we have the lips here, and actually I don't see the pole. Let's see what happened to it. Mm, okay, so this was the operation. I don't know what happened to the sketch. As we use this face and we modify it, that created an issue. So we can just say up to next, but I think it's only necessary to select the face, and that's fine. Oops. I don't know why it's not letting me. So maybe it's going to be just easier to redo it. However, I think it's weird. Okay, let's remove this feature and okay. I don't know what I did that screw up the drawing. So as it is a fast operation, I just will redo it again. Okay. I think this was half centimeter. There you go. And features, extrusion, up to surface, this one. Then right here, create a new sketch. Oops, not edit. Create a new sketch in this face. Or actually, I don't think it's necessary. Let me just try to create the hole. So drill, ISO, M4, and half a centimeter. We are the position. We hover until we see the center for the circle. You say that's fine. There you go. So if we go back to this sketch, we can see that it already has the hole for this. However, we need to do the same but in the back. So let's do that. Click here and we'll go back to file, open, and we'll go back to head. We'll open head back. There you go. So new sketch on this face. There you go. And now we need to create a hole from this part that measures half a centimeter, and we need to extrude it up to this surface. There you go. Now we need to create a hole for the screw. So actually, I think we will need to create a bigger hole. Let's modify this. As the head screw will measure half a centimeter, I believe, it will cause issues. So let's edit this and let's just say 0.7. Okay, so new sketch. Again, so there you go, and this one will measure 0.6. Actually, let's change it to half a centimeter, and let's do a good extrusion. And now we need to have a small gap here. So more or less like this. So now we will need to have the hole for the screw. So actually, I think this whole thing should be a little bit thick. uh, so let's try to modify that, and this one should be, oops, 0.8, and this one 0.7. I don't know. uh, the good thing about SolidWorks is that we can change any values if we encounter errors. So right here we need to create a new sketch, and this should be the actual hole that measures 0.5. So as this little corner is maybe too small, we will need to make it thicker. However, let's first check if there is any interferences. Okay, and well, that's fine. What happened? Let's check. That should have created a hole, but it didn't. What's going on? Let's remove it and create. Oh, maybe I just the regular extrude, and what I wanted to do was to use cut extrusion. Maybe that was it. And up to a surface. This one. Now there you go. So let's see how it looks in our assembly. Okay. So maybe so we can see it a little bit better, we can use this plane, and there you go ish. The centers are aligned, that's the important thing, and the screw should go from here and then stay here. Okay, I think so far so good. Let's just turn the head on. So it's easier to look. Okay. So now, and this is something new, we will be using another feature of SolidWorks that is called the toolbox. So we will go here and click on SolidWorks toolbox. Okay, and what that will do is to open up the design library, and here, as there is so many parts that are already built, such as the screws, well, many parts. We have here the standards, and we have the ISO, or we can have the ANSI inch or metric, and right here we have self-tapping screws, and right here we have a one with the head. Well, let's try to see if this one fits on here. So we click here and drop, and it will ask us what type of screw we want. So M3, I believe that we have selected an M4. So this is, as we see, we have a lot of interferences right here, but this is what the assembly is for, so we can check out whatever is going on. So actually we need to have it on here, because this is where the head should stick, right? Okay, so click and okay, M4, so it doesn't fit at all. M3, so this is doing whatever the hell it wants. Okay, so we detected many issues. Let's turn off these, and we want the screw to touch right here. Okay, let's see, maybe another kind of screw. Self-tapping and X head. We have a whole set of tools. Actually, I think that was the good one. Self-tapping, Avellaneda, causa hexagonal, Avellaneda plana. No, this should be it. ST for let's just click OK. And if we have more, we can just move. So maybe we don't want an M4. Maybe we want something smaller. Otherwise, the screw will be too big. So let's try another size. M3, maybe. Okay, and now let's see what's going on. So this screw is sitting right here on this lip, so that's fine. However, we could improve that this section, this area of contact, to make the screw uh, better. And what else? Let's see if we have an interference, because it's hard to see from here. Actually, we can see the screw is actually coming out. So we could just drag this pole further, so we don't have this interference here, or we can try to change the screw, etc, etc. So let's try to increase the size of this area by clicking here and edit the feature. Okay, and we can uh, change the value for the sketch to be 0.3. maybe just 0.4. Let's see what happens. No, and I think this value is fine. However, the feature can be modified. So instead of 80, let's say 0.6. Now let's go back to our assembly, see what's going on. Okay, so the screw is not coming out, so that's good. Let's see if we can have a better view. And as it is it is moved. Well, not moved. It is the head is turning. That's why we cannot see exactly what's going on. So let's just add this relationship so we can just see it, at least for the moment. We can erase it later if we want the head to turn. So there you go. Now we can see much better what's going on here. Okay, so the area that they are touching is fine, and I think this was the issue. Huh. So I think we can actually go a step further to set this area to increase. However, it is not necessary, and the screw is actually coming out a little bit or not. I'm not really sure. I think this is the hole ending and this is the screw. So we can also increase the depth for this part right here and also increase the height for this pole. Okay, let's do that. Okay, so we need to increase ISO M4, and this is the depth. Let's increase that to 0.8. Maybe because this is only the hole. Okay, back 0.3. And let's go back to the assembly. Oops. We can change the view to the top view right here. So this is M4 and this is, and we have two different thicknesses here, and maybe that is why. However, that is fine because we want to have only el macholeado en esta parte and not on this one. So the screw fits, the hole fits. Maybe we can even set the hole a little bit higher, or this one to a little bit further. However, I think that's okay for the moment. And actually, I don't know what happens if we run interference analysis. So let's do that. Oops, here. No interferences. So I think we're good to go. Um, Worst case scenario, we need to change this one to actually have interference with this screw, which is an M3, which would make sense. So let's do that. Here, edit this feature. So instead of M4, let's change it to M3. That is the type of screw that we are using. So now right here we do have an interference, but I think that we actually want this interference to be there because this will means that we are creating the thread inside of the hole and this assembly would stay together. Okay, so maybe this took us uh, maybe too long, but we need to do this for to hold also the body, and that's it. That's all the parts that we need to hold together. So that would be your assignment for today. If you have any questions, please let me know, and I see you guys tomorrow.